Look at this question. For the circuit in the figure below, the values of ID and VD are. It was a question asked in previous gate papers only, instrumentation paper 2017. Okay, how do we do this? First of all, if you look at this, it's not looking like some kind of balanced bridge and all. Two power supplies are there. So let us take the Thevenin's equivalent circuit for this combination as well as for this combination. Let me write it is Thevenin's 1 and it is Thevenin's 2. What is the Thevenin's equivalent voltage for this case? Let me take that as VTH1. That is 8 volts by 10 kilo ohm plus 10 kilo ohm multiplied with 10k. It is 4 volts. And what about R Thevenin's 1? It is 10k parallel with 10 kilo ohm. It is equal to 5 kilo ohms. Similarly, second part. What about VThevenin's? So with respect to this point, we need to see. Earlier also, we need to look at with respect to this point. Okay. So VThevenin's 2 is equal to 4 into 10k by 10k plus 10k. It is equal to 2 volts, and R Thevenin's 2 is same as that of previous one. 10k parallel with 10k, it is equal to 5 kilo ohms. Then let us draw their equivalent circuits. Four volts, 5k, 2 volts, 5 kilo ohms. In between the diode, this current is ID and this voltage is VD. Now look at the diode. The anode of the diode is going towards 2 volts and the cathode is going towards 4 volts. So anode is at a lesser voltage compared to cathode. Diode does not conduct. Once the diode is not conducting, it simply acts as open circuit. So further we can draw the circuit this way. Anyway, the diode is acting as open circuit. 2 volts, 5k, anode and cathode. What is the voltage at this point? Is there any current that is possible? No. Anyway, as we discussed, no current is possible. So let me take this voltage as VA. So VA is equal to 2 volts. Next, is there any current that is possible here? Here also there is no current. It is 0. So what is the cathode voltage? 4 volts. VC is equal to 4 volts. And what about VD? VD is nothing but VA minus VC, cathode voltage minus. So we have got VA and VC. So VA minus VC gives us VD. We are well aware of it. So VD is equal to VA minus VC. It is 2 minus 4 minus 2 volts. Definitely. Right, anode to cathode should be, cathode voltage should be negative as the diode is not conducting. Okay, so option C is correct. The current through the diode is 0 and voltage across diode from anode to cathode is minus 2 volts. That's it. Next. For the series diode configuration of the below figure, determine the value of ID. What is the current through the diode? Okay. So if you observe this, the anode of the diode is going to positive terminal of the 8 volt supply and the cathode is going towards the negative terminal of the supply. Definitely the diode conducts. Okay, so nothing is mentioned about the diode. First assume ideal diode. That's the very first step we have been doing so. So assume ideal diode. Of course, the diode conducts. Second point. If so, ideal diode means a short circuit. So we can write here ID, current through the diode. It is given by 8 volts. Once it is okay, silicon diode they mentioned. Okay. First, let us check with ideal diode. As it is mentioned as silicon diode, we should be careful, right? So we cannot take ideal diode. Sorry, friends. Okay, I'm just erasing this. Sorry, we cannot assume ideal diode. It is mentioned silicon. The only thing I can say is diode conducts. Okay, sorry. And once the silicon diode is in conduction, voltage across the silicon diode is in general taken. We take it as 0.7 volts. Okay, so diode conducts is the first step. Next one is assume VD, voltage across the diode, is 0.7 volts as it is mentioned silicon. If that is the case, what is the current through the diode? ID. What we can write? So voltage across the diode is 0.7 volts. Then if I take this loop equation, what we can write? Minus 8 plus 0.7 volt plus ID into 2.2 kilo ohm is equal to 0. Okay. So that what about the current ID? It is 8 minus 0.7 by 2.2 kilo ohm. How much do we get? It is 7.3 by 2.2, 73 by 2.2. If you take it so, you will get it around 3.32 milliampere. I'm directly writing it. Okay, that's it. So option C is correct. Okay, sorry friends, here even though they have not mentioned in the data, but here it is mentioned silicon diode. Okay, and hence we can't take it as ideal diode. We can assume this one voltage across diode once it is in conduction means 0.7 volts as it is silicon diode. Then we can see the result. If I take ideal diode, what might be the answer? If the diode is ideal, then I is equal to 8 by 2.2. Okay, 8 by 2.2 K. How much do we get? 3.63. So even if we assume ideal diode also, that is close to option C only. Okay, it's not close to A, B or D. Okay, but nothing to worry about it, right? As it is mentioned silicon, we are taking voltage across diode as 0.7 volts once it is in conduction. That's it. Look at this question. For the circuit shown below, assume V gamma means if the diode is forward biased, once it is in conduction, voltage across the diode is 0.7 volts. The value of V output is, okay. Look at the diode terminals, anode and cathode. Anode is going to 10 volts and cathode is going to -5. The diode will definitely conduct. The diode conducts. Once the diode is on, voltage across the diode will be 0.7 volts. So here only I am writing 0.7 volts. Then what about V output? How do we find it? For that, we can find the current through the diode. We can use nodal analysis to find V output directly. Otherwise, we can find the current through the diode later V output is equal to current through the diode multiplied with 2.2K minus 5 volts. That is another way of doing it. So anyway, I would like to go with nodal analysis. Let me take this node, right? Apply KCL at node C. I am writing cathode. No, let me write it. KCL at node C. I am writing. So V output minus of minus 0.7 here. V output VD has polarities plus minus from anode to cathode 0.7. That's why. Next minus 10 by 4.6K plus V output minus of minus 5 by 2.2 kilo ohm is equal to 0. Okay. Now we can easily rearrange the things and do it. So that how much do we get? It comes to be around, if we do it so, I'm directly writing the answer. It is minus 0.38 volts. Students are requested to look at the calculations. Okay, this is one simple way of doing this problem just by nodal analysis. Once you understand that the diode is in conduction, आराम से KCL अप्लाई कर सकते हैं. बस एक स्टेप में हमको आंसर मिल जाएगा. Alternatively, what we can do, we can find the current through the diode. Next, we can write V output. That is a bit time consuming process. Okay, alternatively, I will do it in the next line. Alternatively, let us take the current. How do we find the current in the circuit? Okay, I will redraw the circuit otherwise. Ten volts, 4.6K, and voltage across diode will be 0.7, 2.2K minus 5 volts. Okay. Then we can take this current as I. What we can write for I? Or 10 volts is equal to I into 4.6K plus 0.7 volts plus I into 2.2K minus 5. If I take this loop equation. Okay. So what is I? From this, I is equal to 10 plus 5, 15 minus 0.7, 14.3 by 6.8K. Right? It comes to be around 2.1 milliampere. Okay, I'm rightly writing the answer here, 2.1. And what about V output? V output means this is V output. I into 2.2K minus 5. It's a bit lengthy procedure, no? Right? We can understand 2.1 into 2.2 minus 5, and it is found to be 0.38 volts with negative sign. Okay, that's it. It is a bit lengthy procedure. Instead of this, just with nodal analysis, we can write the answer this way. Okay. Next. Assume that the diode shown in figure has V on is equal to 0.7 volts, but is otherwise ideal. The magnitude of the current I2 is equal to, okay, what is the current through? 6 kilo ohm resistor. Okay. So first of all, if you observe this, the anode of the diode is connected to plus 2 volts and the cathode is going to ground. Diode conducts. Definitely. It looks like, right? Looks like diode is on. Assume diode conducts. If so, because the moment you see the circuit, it gives a feeling that diode is conducting. Okay, that's why I'm writing it so. Then what will the voltage across diode? 0.7 volts. So I'm redrawing the circuit. The same 0.7 volts can be seen across this 2 kilo ohm resistor as well. If that is the case, let me take this voltage as Vx. What is Vx? It is 2 minus 0.7. So Vx is equal to 2 minus 0.7. It is 1.3 volts. Okay, we got Vx value. Then what about this current I2? I2 is equal to Vx by 6k, 1.3 by 6k. So it comes to be around 1.3 by 6. Let me take some calculations. 0.216 milliampere. Okay, I2. Then let me take this current as I1. What might be I1? See, it's not like simply we can relax with the answer we have got. Always, especially in this kind of problems, we should go through, we should find the current through the diode. Then only we can make the conclusion. Okay, what about I1? I1 means the current through 2K. So voltage across 2K is 0.7 volts by I1. It is equal to, sorry, by 2K. It is equal to 0.35 milliampere. I1 is equal to 0.35 milliampere and I2 is equal to 0.216. To be frank, I2 is equal to I1 plus ID. Is it not so? If I take this current as ID. So I1 is positive. Current through the diode should be positive. Anode to cathode current should be positive as the diode is on. If that is the case, I1 plus ID should be greater than I1. It's a very simple common sense point. But here what you are getting, I1 is 0.35 milliampere and I2 is 0.216 milliampere. Is it possible? I2 cannot be less than I1, or I can write ID is equal to I2 minus I1, which is negative. Not possible. Okay. See, it looks like anode of the diode is connected to positive terminal of the supply and cathode is connected to negative terminal, but the diode is not able to conduct. Okay, that is why it is happening so. That is due to the resistor 2 kilo ohm we are connecting. If the 2 kilo ohm is not connected, then definitely the diode will conduct. The 2K connected across the diode is not allowing the diode to conduct. This is the interesting thing about this problem. Okay, so diode is, it is not possible. So diode is not conducting, we can say. If that is the case, okay, what about the current I2? Okay, if that is the case, what about the current I2? See this. So diode acts as open circuit. I'll do it in the next phase. The diode simply acts as open circuit. Two K, 6K, and I2 and I1 both are one and the same. Okay, sorry, 2K, 6K. I need to interchange them. 2 volts, 2K, 6K. I1 is equal to I2 is equal to 2 volts by 2K plus 6K. It is 0.25 milliampere. That's it. Okay. This is the current. See, if you really satisfy, if you feel like this is only the answer, and if you stop it, you will be in trouble. When there is, whenever a resistor is connected parallel to the diode, we should be very careful, right? It's not like simply the diode is in conduction. The resistor you have connected across the diode may affect the right the diode to not to conduct. Okay. If so, what might be the anode voltage and cathode? Anyway, anode is connected to 2 volts. Anode is right at 2 volts. And what about the cathode voltage? Voltage across the diode cannot be 0.7 volts. It might be less than that. How to find it? Let me take this voltage as Vx as usual. Let us find that Vx. This Vx or voltage at the cathode of the diode. So Vx is equal to I2 into 6K. It is equal to 0.25 into 6 milli and kilo cancel. Okay. So its value is equal to 1.5 volt. Okay. So if you observe the diode, right here we have the diode. The anode of the diode is 2 volts anode voltage and cathode voltage is 1.5 volt. Vx means voltage at the cathode. So anode to cathode voltage, if you see 0.5 volts, that is not sufficient to make the diode to. Okay. So that's how this 2 kilo ohm resistor is influencing your circuit. The effect of the 2 kilo ohm resistor connected, if you see so, that is not allowing the diode to conduct. This is the interesting thing about this problem. Always it is there. Okay. So please don't conclude directly like yes, is anode is at a higher voltage. It looks like compared to cathode, diode is in conduction and hence the Vx is 0.7 and IT is equal to 0.216 milliampere, which is absolutely wrong. It is really a big trap. Okay, people do not observe. Whenever you see a resistor connected across diode, better you find ID and then you can conclude. Without finding ID, don't conclude anything. Very, very important point here. Okay, once the diode is on, then okay, once the diode is in on state, current through the diode should be positive. Anode is at a higher voltage compared to cathode, means higher to lower potential. The current should be positive, but you are getting negative current, which means the anode to cathode potential difference is right maybe less than the on state V on. Okay, that's the idea here. Okay, look at the next question. The same problem. I just for the sake of better understanding, I just slightly changed the values. Okay. So if you look at this problem, Here also the procedure does not change. See, if this 2K is not present, we need not bother. Directly diode is on and I2 is equal to 2 minus 0.7, that is 1.3 by 2K. Okay, 0.65 milliampere, something we can write it. But a 2 kilo ohm resistor is connected. How this is influencing our diode? Okay, here also by default what we take, assume the diode is on state, right? Anode and cathode terminals. Just by observation, by looking at it, it looks like the diode is on. So assume diode is on. If so, voltage across the diode will be 0.7 volts. If that is the case, if I take this Vx, it is equal to 2 minus 0.7, 1.3 volts. So that I2 is equal to 1.3 by 2, it is 0.65 milliampere. Okay, we may be concluding like this. It looks like very simple, but always find the current through the diode. Then only you can conclude the result. Let us take this current as I1. So what is I1 here? It is voltage across 2K is 0.7 by 2K. It is equal to 0.35 milliampere. Yes, I1 is 0.35 milliampere. I2 is greater than I1. Definitely ID will be positive, no doubt about it. Because right, I1 plus ID is equal to I2. And hence ID is equal to I2 minus I1. It is positive. It is 0.3 milliampere. 100% our assumption is correct. Then I can say absolutely I2 is 0.65 milliampere. That's it. It all depends on how the resistor connected across the diode is. Okay. Right. What is about its value? See, in this problem, it is taken as 2 kilo ohm, whereas previous one, okay, this resistor, right, even you can change this 2K, right, or this 6K, any, right, we do not know how the resistors are chosen. Here 2K and 2K, that are that combination is allowing the diode to conduct, whereas previously 2K and 6K, that combination is not allowing the diode to conduct. You can change the values. Okay, that's it. This is how we can conclude the problem. When diode with multiple resistors means, always it is not like simply the diode conducts. We should find the current through the diode for final conclusion. That's very, very important. Next, look at this question. A silicon diode shown in figure has a barrier potential of 0.7 volts. There will be no forward current flowing through the diode if VDC in volts is greater than. What should be the value of this voltage so that there is no current, forward current flow? So current through the diode will be 0. What is VDC? So that the current through the diode is 0. For the diode to be off, okay, voltage across the diode should be less than 0.7 volts. That's what we can see. We can observe from the previous problem. Here what happened? Right, we observed that the diode is okay, ID is negative, so diode is not conducting, we have seen. If so, what is Vx? We calculated that. How much we have got? Vx is found to be a 1.5 volts. So anode voltage minus cathode voltage, it is our voltage across diode is 0.5 volts, which is less than V gamma, and hence the diode is off. In a similar fashion, if you observe this, for the diode to conduct, voltage across the diode should be at least 0.7 volts. Then only ID is possible, otherwise ID is not possible. Okay. Suppose the diode is on, then what about ID equation? Right? If the diode is on, It is 0.7 volts, 2 volts, and this current is I or ID, anything. We can write it. ID, let it be. Then what is ID? Or I can write here, if I take the loop equation, 2 volts is equal to 0.7 volts plus current through the diode into 0.5 K plus VDC by 2. Okay. So what is ID? ID is equal to 2 minus 0.7, 1.3 minus VDC by 2 by 0.5 K. If the diode is on, then the current through the diode is given by this equation. But to be frank, what they are asking, what is VDC? What is VDC? So that ID is 0. That's what they are asking. So for ID to be 0, we should equate. So for ID to be 0, what might be the value of VDC? So if ID is 0, then VDC is equal to 1.3 into 2, that is 2.6 volts. Okay. If VDC is equal to 2.6 volts, then there is no scope for the diode to conduct. If VDC is less than 2.6, then there is a scope for the diode to conduct. That's it. This is how we can do this problem. Okay. So it's not like every time the diode will simply conduct the condition. Yes. Look at this one. A diode in the circuit given below has V on is equal to 0.7 volts, but is ideal otherwise. The current in milliamperes in the 4 kilo ohm resistor is, get 2015 electronics paper set. How do we do this? Whenever you see this kind of bridge, check whether it is a balanced bridge or not. Instead of voltage source, they kept here current source. All these things are just to confuse us. Look at the bridge is balanced or not. Here 2K by 4K is equal to 3K by 6K. Absolutely, it is a balanced bridge. Okay, it is a balanced bridge. Once it is a balanced bridge, this voltage, if I take VA and it is VB, VA and VB are equal. VA and VB are equal means, is there any current possible through the diode? No. Simply the current is 0. Diode does not conduct. Here VA is equal to VB and diode does not conduct. As the diode is not conducting, simply the current through the diode will be 0. It is 0 milliamperes. That's it. Okay. And see the next question. Based on, right, whatever they are asking, based on that we are trying to create our own problems. Suppose the bridge is not balanced. They may give a question in which the bridge may be unbalanced. Then how do we do it? See the next question. The diode in the circuit given below has V on is equal to 0.7 volts, but is ideal otherwise. Determine the status of the diode. I created a problem in which complexity is less. I don't want to find the current through the diode. I tell you why. And instead, I'm asking you to find the status of the diode. How do we do this problem? Again, here what we can do. So far, the problems, if you see, we have assumed that the diode is in conduction. Okay, here also, if you take the polarities of the current source, top plus and bottom minus, but the diode is kept this way. Here, how do we decide? Check first of all the bridge is balanced or not. 2K by 10K is not equal to 3K by 6K. It is an unbalanced bridge. Once the bridge is under unbalanced condition, there is a scope for the current to flow through the diode. No doubt about it. We need to find that, of course. They are not asking to find the current, right? Status of the diode. That's it. So how do we do this? First time I'm taking, assume the diode is off. So far we did the problems with diode is on, because we could able to trace it. It looks like diode is on. Every problem, whatever the problems I have done so far, if you observe, so it looks like anode is at higher voltage compared to cathode. That's why I did say. But here you are unable to decide. No, क्या कर सकते हैं, right? इसलिए हम डायोड ऑफ एज्यूम कर सकते हैं. Okay, assume diode is off. If the diode is off, what is the equivalent circuit? Two K, 10K, 3K, 6K. Anyway, it is ground. Then let me take this current as I1 and this current as I2. Anyway, this is 1 milliampere source. Once I find I1, I2 values, then I can find VA and VB. VA minus VB is greater than 0.7, then diode will conduct. If VA minus VB is less than 0.7, diode is off. That's it. It's as simple as that. Then how to find I1 and I2? Current division rule. So I1 is equal to 1 milliampere by all the resistors 2K plus 10K plus 3K plus 6K. Okay. 1 by 21. Sorry, it's a by opposite resistors. Sorry, current division rule. So total current by sum of all the resistors multiplied with our resistors, sum of the resistors in the opposite of, that is 3K plus 6K. Okay, it is 9 by 21, that is 3 by 7 milliampere. And what about I2? I2 is equal to 1 milliampere by the same, all the resistors 12 plus 9, 21K, sorry, 21, yes. Multiplied with 2K plus 10K, that is 12K. It is 4 by 7 milliampere. Okay, I1 and I2 are like this. I2 is greater than I1. Let it be. Then find VA and VB. Okay, what about VA? VA is equal to I1 into 10K. We can write I1 into 10K gives us VA, and I2 into 6K gives us VB. 3 by 7 milli and kilo cancel, 30 by 7, right? If you take it, it is equal to 4.285 volts we get, and VB is equal to I2 into 6K. It is 4 by 7 milli into 6K. Milli and kilo cancel. It's 24 by 7. 24 by 7 means it is 3.428 milliampere. Sorry, 3.48 volts, VA VB in volts. Then what about VA minus VB? If you observe, so 4.285 minus 3.428, it is found to be 0.857 volts, which is greater than V gamma. As it is greater than V gamma, definitely the diode will be conduction. Definitely diode conducts. Once the diode conducts, VA minus VB cannot be 0.857, it will be 0.7 volts only. After that, again using network analysis and all, we can find the current through the diode, right? Current divisions, etc., voltage division, whatever may be the thing. Nodal analysis or loop equations, everything, right? Anything you can use to find the current, which I am not doing. That is left to the students. Okay. So this is the idea. Once the diode is on, okay, just for your information sake, I'm just giving you the idea of finding the current through the diode. In the exam, they don't give this much lengthy problem. They may ask us to find the status of the diode if that is the case. Okay. So here, two K, 10K, 3K, 6K. I think it is 1 kilowatt. Okay. Then if they ask us to find the current through the diode, how do we do it? We have understood that diode is on and voltage across diode is 0.7 volts. That's it. Then remaining steps, just I'm giving the idea, not doing the all the things. Assume this current is I1 and this current is I2. Okay. And this current is I3 and this current is I4. Okay. Then we can take this as loop 1 and this one as loop 2. KVL to loop 1. You will get one equation in terms of I1, I2 and ID. Okay. And I1 plus I2 is equal to 1 milliampere. I1 plus I2 is equal to 1 milliampere. If I take the loop equation, I1 into 2K plus 0.7 plus ID into 1K minus I2 into 3K is equal to 0. Now, instead of I2, I can write I1 minus 1 milliampere. So, I will be getting one equation in terms of I1 ID only. Simple point. Okay. Similarly, we can take this second loop L2, right? L1, loop 1 implies. L2 implies, here also we can do it, ID into or 0.7 volts plus ID into 1K plus I4 into 6K minus I3 into 10K is equal to 0. We can write it so. Okay. I will do one thing. Loop 2 implies 0.7 plus ID into 1K plus I4 into 6K minus I3 into 10K is equal to 0. Okay, just rearranging the things only. And what about I4? It is equal to I2 plus ID. What about I2? I2 is equal to, okay, 1 minus I1, 1 milliampere minus I1. So I4 is also written in terms of ID and I1. And what about I3? I3 is equal to I1 minus ID. I3 is equal to I1 minus ID. It is a laborious process, of course. So ID and I3 and I4 can be further written in terms of I1 and ID. So by solving this equation and this equation, we can find the values of I1 and ID. Anyway, first what we require is ID. ID can be found. It's a bit laborious process. That's why I have not continued further. I have taken the problem as find the status of the diode, determine the status of the diode. That much only I took. Okay, this is the idea. If the bridge is unbalanced, they won't ask to find ID and all. If so, we have seen the procedure. Okay, this is the idea. Next, so far we have done the problems with a single diode. Now I'm starting the problem with two diodes in the circuit. See this. Assuming that the diodes in the given circuit are ideal. Okay, they mention ideal. Okay, short circuit, open circuit. That's it. If they give V gamma, then based on that V gamma, we do the problem. Okay, the voltage VO is what is V naught. If you observe this again, look at this diode. Let me assume this is D1 and this is D2. Anode of D1 is going to 10 volts and the cathode is going towards ground potential. And what about D2? Its anode is going towards minus 15 and cathode is going towards ground. So by observation, we can say D1 is on and D2 is off. So it looks like D2 is off. Okay. So here we can take this directly just by observation. Whereas in the previous problem, is it possible to take so? Diode is on or off? No, we are unable to. And as it looks like a bridge, I assumed diode is off and I did the calculations. But in this problem, if I start my analysis with an assumption of diode is on, you can understand how much laborious it is finding. I have to do all those things. If the diode is on, I need to find I1, I2, ID, etc. And if ID is negative, then diode is off. Our assumption is wrong. And right, ID is positive, diode is on. Right. But here, what I did, just I started with an assumption of diode is off and did the calculations. It all depends. Right. It's not like for every problem we have to assume diode is on, or for every problem we have to assume diode is off. Few things can be done with observation. And bridge problem, it's better to go with diode is off instead of diode on. Okay, so if that is the case, it is open circuit and it is short circuit. So in this, I2 is equal to 0 or ID2 is 0 and ID1 will flow in this direction. So that V output is equal to 10 volts by 10 kilo ohm plus 10 kilo ohm voltage division rule into 10k, it is 5 volts. Okay, V output is 5 volts. And what about the voltage here? Once it is short circuit, the voltage here will be 10. So cathode is going to 10 volts and anode is going to 15, sorry, minus 15, and hence the diode does not conduct. D2 does not conduct. Only D1 conducts. Okay, this is the idea.